Good afternoon, everyone, and welcome to the fifth of 6 workshops with Dr. Janita Pritchett. Today we're going to be having fun with microscopes. If you've missed any of the previous sessions, and please check the Scifest YouTube or Facebook pages, and you can catch the replays there. If you have any questions today, please unmute yourself and ask. Otherwise, you can post in the chat and we will pass the questions on to Dr. Pritchett. Please follow the Scifest Facebook pages for more info on any workshops and sign up for their newsletter. Otherwise, Dr. Pritchett, let's take it away.
Thank you so much, Ryan, and good morning from the US. Good afternoon to those that are in South Africa. I hope you all had a wonderful week, and we are about to get ready to steam forward. So for those of you that have been on this journey with us, as Ryan mentioned, we are on our 5th week with Steam Forward. And we've done a lot of fun things. We started off first by learning how to blow up balloons with chemistry, doing some simple reactions with acids and bases. We then learned how to make our very own ice cream using exploring physical and chemical changes. We learned how to use chromatography to make butterflies and flowers. And we also, last week, we learned how to float an egg with density. So today, we're actually going to be doing more of a demonstration where you guys are going to be watching what I'm doing and being able to make observations. So hopefully most of you have heard of a microscope before. And microscopes are really important in the STEM field. So for science, technology, engineering, and math, microscopes play a very big role in a lot of different disciplines, okay? Now, I have always been into science, and I can assume most of you all like science if you're joining us today. And so when I was younger, as I've mentioned before in the past, both of my parents were scientists themselves. They're nuclear engineers. And so they would always expose me to different science topics and take me to computer camp and things like that. And so one of the things I asked for when I was younger was my very own microscope. And so I went home a few weeks ago and I actually picked up my actual very first microscope that they had at the house. And so we're going to talk about how microscopes work. But then I'm going to also show you a different type of microscope that allows us to see digital images as opposed to the traditional microscope that you guys may be familiar with. Okay? So how does a microscope work? What's the purpose of it? Well, microscopes take very, very small things and magnify them and make it easier for us to see. Okay? So inside of a microscope, and hopefully you all can see this image, most basic compound microscopes are set up like this, where you have a stage area where you put your sample. There's a light source here that shines a bright light up toward that sample. There's this objective lens, which actually magnifies that really, really small sample to make it bigger. And then another lens up here, the ocular lens, that makes it bigger for you to see. Now, the objective lens, typically in a microscope, you have the ability to switch them out. And so if you look at my old microscope here, you can see that there's this part that can rotate here. And that rotating piece allows me to pick how big I want to magnify things. And the reason we have this is because sometimes when we look at things from the macro level, meaning the big level, they look very similar. It's hard to tell the difference between two things. But when we look at things at the micro level, that's where we can really see differences in colors, in the shape of things. And so I'm going to take you guys through a lot of different examples of things that we can look at under a microscope so you can see what differences we are able to be seen. Microscopes are used in places like forensic science. If they're trying to identify if a sample matches a suspect, it can be used in a hospital or in a research lab to look at cells. So you use microscopes for a lot of different things, okay? So if we could switch quickly to my other camera just so we can see the two different microscopes that we're going to work with. Thank you. All right. So as I mentioned, this is my first microscope, okay? It's a regular compound microscope, several different objective lenses here that you can rotate to see your sample. Battery powered, there's a light source, and we would be able to see under here. Now, if I was only using this today, while I would be able to see what we're magnifying, you, the audience, wouldn't be able to see this. And so what we're going to use today is actually a USB microscope. So you can see it looks somewhat similar to our standard microscope, but it is different, right? So some differences that we see. Well, one, I no longer have this stage area that's all connected to my microscope. My stage is now just a platform that I can adhere this microscope to. I also, the lenses that are in here, they're inside of this microscope as well, just in a more condensed form. And then the light source is controlled up here from the top as opposed to the bottom. Unlike this microscope, this does not have that second lens inside of there, so the image ends up being inverted, what we're going to end up seeing. But we're able to magnify things up to 250 times bigger than what they would be in normal circumstances. And so what this is going to allow us to do, I have a lot of samples that we're going to look at under the microscope, but we're going to see how we can use a microscope to see some distinct differences, okay? So can we spotlight my original camera, please? I'm going to go ahead and turn on my microscope so that we can start looking at some stuff. All right. So again, this is the microscope. You can see the grid lines. You can see my finger under there now, okay? And so you can see we are actually seeing things in real time. So some of the cool things that we can look at under the microscope initially are things like money. Money is one of the funnest things to look at under the microscope because you'd be surprised how many different things are embedded in money to help ensure that people cannot make them counterfeit. And so for those that are joining me from South Africa, this is just a South African rand that I had from one of my travels there. And so if we look at it under the microscope, we can start seeing all this detail that exists within the actual note. You can see there's this kind of holographic image here on the 10. You can see some other things that are really embedded within the bill. And you can see all that detail. And so all that detail is what we look at when we're looking to see if something is indeed counterfeit. You're looking to see that these images, these pieces, are actually in place, okay? For my US folks, I have a US bill here as well. You can see we also have some of the similar things where we have watermarks and other things that are embedded within the bill to ensure that, again, someone cannot easily counterfeit or make a fake one, okay? You can look at coins as well under here. And that's where you can really see so much more detail that exists on these small images or small objects because our microscope is able to magnify them 250 times larger, okay? All right, so we now all understand why we use microscopes. And again, I'm going to be showing you guys some things. We're going to look at them under the microscope. And I want you to kind of guess what are the items that I'm showing you. So real quick, can we spotlight my the video camera real quick? All right. So we have two different things here in this Petri dish. Hopefully you can see them. Now, if you look at those two piles, you notice that they look very similar, right? If we were to describe them, you might say that they are white, they're solid, they look like they're crystalline, they look like they're the same thing, right? At the macro level, the big level. However, when we look under the microscope level, we're going to see some differences. So I'll tell you now, these are not the same thing. One of them is sugar and one of them is salt. And so let's take a look at them under the microscope. So go ahead and please switch to my microscope camera. We're going to look under the microscope now. All right, so this is our first sample here. And what do you notice? Take some observations. You may notice that, and I can adjust the focus a bit so we can really see. But something you may say, well, I see some crystalline pieces. It looks it's still solid. It is definitely white. It's shiny, almost looks like glass a bit. Okay, so that's the first sample. So remember what that image looks like. Now take a look at the second one. You should see some differences there. If anybody wants to unmute themselves, you can yell out if you see something that looks different between this second sample versus.
It's not as shiny.
Good, it's not as shiny. What else do you notice? Do they look like they're the same size particles?
No, they look like they're different particles.
Yeah, they're different sizes. So you can see that there's less shiny, more defined crystal particles, a bit bigger, compared to these really shiny particles that are a bit smaller. So the shiny one, what do you guys think? You think the shiny ones are salt or sugar?
Sugar.
You think it's sugar? Okay.
Yeah.
Anybody think it's salt? All right. You are correct. So this one is our sugar. So yes, that is sugar. And then over here, this is our salt. Very good. So again, even at the macro level, we may have got those two confused, but under the microscope, we can magnify these things and see them a little better. All right, we're gonna go to the next sample. Can we switch real quick back to my video camera? Thank you. All right, so 2 more samples here. Again, they also look white. So if you just saw these near these, you may say, hey, well, maybe these are all the same thing at the macro level. But again, when we look at these things at the micro level, can we switch back to my microscope, please? We're gonna see some differences, all right? So this is sample, we'll say this is sample 3. Now, compared to those first 2 samples, what's something you notice? Again, you can unmute yourself and yell out something you may notice.
It looks much more flowery.
Much more flowery, very good. It's not shiny, it's not crystalline. You can see that there's actually some other little speckles of things there. All right, so actually, you were correct. This is actually flour. And so you can see the little brown specks actually are wheat, some unground up wheat that is still remaining, okay? Now look at this sample. This is the 4th sample. Again, compare this to the ones you've seen. What's some things that you notice about this one?
It looks much finer than the other one.
Much finer, okay? Do we see those little brown specks in there in this one?
No.
No, so if we had to compare this one and this one, would we say that they're the same?
No.
Absolutely not, good. And so this one, I assume you guys may have this in South Africa, this is actually cornstarch. And so that's another ingredient that's used in cooking and for other ingredients. If you ever made slime, it's one you can use it for slime and things of that nature. All right. So again, at the micro level, excuse me, we can start picking out these differences. Very good. All right. So we're going to switch from our white substances to more of these neutral color substances. So we switch back to my video camera, please. Thank you. All right. So now when we look at these ones at the macro level, we can see differences in color. We know that they're probably not the same, but at first glance, this one and this one, they do look fairly similar, just slight differences in color, okay? So we're gonna look at these under our microscope. All right, so we switch back under the microscope. All right, so let's start over here. And again, anybody else, if you feel like unmuting, feel free to tell me something you notice about this sample.
It looks like dirt.
It looks like dirt. This is actually something we eat, so it's not dirt. Right? But there does look like there's a lot of stuff going on in there. Okay. Now let's remember what this looks like and compare this to, bring it in focus a bit more.
It looks like some sort of spice.
Okay, good. I hear someone saying that it's spice. It's actually chili powder. And so you can actually see some of the crushed red peppers that are still remaining in this spice. Very good. All right, so I'm going to rotate to the next one. Okay, now again, notice, does this look like this would be as spicy as the one I just showed you?
No.
No, very good. So this is actually smoked paprika. And so paprika is, again, another just spice that you can add to different things that you may cook. Okay, good. But again, under this micro level, we can actually start seeing some really distinct differences. And then last but not least, we're going to go to our very last one. Take a deep breath. Does this look like it would be as spicy as that first one?
No.
No? Any guesses on what you think this might be?
It looks like
powder.
I think I heard someone say it. What did you say?
Turmeric.
Turmeric. Very good. This is turmeric powder. Very good. Awesome. All right. Let's switch back to my main video camera, please, so we can look at the next set. All right. So again, these two here on the bottom macro level look very, very similar. Maybe the same thing. And then this one's a bit brighter, but still in that. Let's go ahead and check out under the microscope. hearing a bit, like a bit of feedback here. Okay. All right. So that's what this one might be.
Spice.
So it is a spice. It's something that you may put in hot cocoa or on rolls.
Chocolate.
Cinnamon. Cinnamon?
This is actually cinnamon. Very good.
Yes.
All right. So again, you can see that we don't have those red peppers in there bobbing out. All right. Now, that's cinnamon. What do you think this one? And this one is actually in that same family. You may use it in similar things. Some differences.
No.
All right. This one may be a little hard to guess. This one is actually nutmeg.
Sure.
We use that in certain things we cook. And then last but not least, take a look at this one. Okay, we automatically notice the color change.
Hi.
What do you guys think this one is?
Chicken spice?
No, not chicken spice. This one is actually ginger.
Ginger.
Yeah, ginger. Got some crushed ginger. Okay, good. All right, we got a couple more that we're going to work through. We're going to now switch to some leaf material. So can we switch back to the other video camera, please? Thank you. And this is really important, like especially when you're looking, if you work on like a forensics lab, sometimes you may find things that you suspect may be illegal. And so they will look under a microscope to try to tell the difference. All this stuff is all spices, so don't worry, or things that we use in our household. But again, at first glance, these look very similar. All look leafy, green, can't really tell too much about it. Okay, so let's look at under the microscope. So we can switch. There we go.
I think those are leaves. Grass leaves.
So this isn't grass. This is something we can eat. We eat it inside of our house. We put it on our food. Notice there's some dark green, yellows.
Parsley.
Someone said it. That is parsley. Very good. Very good. All right. So let's go to the next. Again, remember what these leaves look like, how big they are, the colors, and then let's switch to the next one. Yes, on this one. And this one, it's actually a little bit difficult to tell the difference between this one and the last one. Any guesses on this one?
Chicken spice. Herb.
All right, this one may be a little difficult to guess. This is actually cilantro, dried cilantro. All right. Again, a little bit smaller. Again, it's a bit difficult to tell the cilantro and parsley apart from each other under the microscope. So we would probably do a different test to make sure we know what it is. All right, and then this is the last one. Notice it's definitely a lot lighter than the previous two. Any guesses on what you think this could be?
Are those tea leaves?
Not tea leaves, but they do look just like tea leaves. They do look very similar to tea leaves. All right, so this is actually oregano. So this is used in some like Italian dishes, but that is oregano, dried oregano. And then the last one we're going to look at. They look very similar, color-wise, at the macro level. Maybe difficult to tell the difference between the two. So now if we go under the microscope. Okay. Any question or any thoughts on what you think this could be? Notice again, we don't see the leafy material. It is those look like a spice. Any guesses of what that might be?
Are those tea leaves?
Nope, not tea leaves.
A lichen.
This is actually pepper. Yeah, I heard someone say this is actually pepper. Very good. All right. And this the pepper that you can use, like you can grind it out of a grinder. All right. And last but not least, Any guess on that one?
Tea leaves.
No tea leaves, but you know what? I'm gonna show you some tea leaves because I want you to be able to see what some tea leaves would look like. All right, so this last one, this is actually also pepper. So this one is just coarse ground pepper. So you can see that the particles of the pepper here are much bigger than this finely ground pepper. And so it's the same thing. We've just taken this one and grind it up a lot smaller to get smaller pieces out. Okay? So again, at the microscopic level, we can start seeing these differences. I am going to open the tea bag real quick for you just so you can see what some tea leaves will look like. Rip open a tea bag. This is what, that was one thing I loved. You guys in South Africa have some amazing tea. I love the rooibos tea. That was one of my favorites to get.
I also love rooibos tea.
Yes, so this is what your tea leaves look like under a microscope. And so you can notice there's a lot of different things that are inside of your tea bag. Who knew that this is all what was going into to make those delicious drinks? So that is your tea. And you can see there are some leaf particles, other stuff that looks like there's more than one thing here. We would classify this as a heterogeneous mixture because there's all these different pieces that we visually see differences for. All right. So I'm going to go ahead and switch back to my main camera. That's my coffee cut. All right. So I hope you guys enjoyed that quick demo. I know you guys didn't get to do anything with your hands, but you did get to really practice making those observation skills. So I wanted to show this because this is a really great activity that you can do at home if you get your hands on one of these little microscopes. You can order these microscopes. This is called a USB microscope from Amazon. Or we have a store called Walmart here that we can also order from, but on Amazon, if you go to amazon.com, I believe even on the .zeta side, so amazon.zeta maybe, go to Amazon and just look up USB microscopes. You can get one of these and you can explore them at home. You can look at all cool types of things under there. You can look at hair under there. You can look at fingerprints. Oh yeah, actually, I did want to show you fingerprints. Forgot I did this. So I'm going to show you what fingerprints would look like under here. But you can look at so many cool things. And so this becomes a really great learning activity that you can explore at home. So let me get my tea out of the way. So you can also look under the microscope, like in forensic labs, they use microscopes to look at fingerprints. And so you can see here, these are actually mine. You can see a lot of detail here. You can see different patterns that exist in the fingerprints. There's a loop, there's loops and whirls. So you can see this kind of, this category, this pattern here. And so looking at fingerprints under the microscope, they're going to be comparing samples that they've collected at a scene to those from someone that they're trying to compare against. They look to compare to see the different detail that's there to see that it's the same person. So my fingerprints have something called incipient ridges in them. And so I actually have like double sets of fingerprints here. So I'm very easy. So yeah, so that's something cool. But again, you can get these microscopes on Amazon, or if you just search for them online, they're called USB microscopes. And this is a great learning activity that you can, once you have it, you can always figure out new ways to explore and find new things to look at under your microscope. So are there any questions from the audience today? Any questions? Well, I hope you all enjoyed it. So we're going to be finishing up this session of STEAM Forward next week. I hope you all can join us. We're going to be learning how to extract extract DNA from strawberries. And so we're going to learn all about what DNA is, and you guys are actually going to be able to go through the steps to be able to take and extract the DNA out of the strawberry material. So please plan to join us next week. Again, if you missed any of our previous sessions, go to YouTube, Scifest Africa's YouTube page or the Facebook page, and you can. Hope you guys enjoyed, and I will be back next week for our final session. See you guys next week.
Thank you.
Thank you.
Bye.
Bye.